What is the speed of a wave on a piano C4 string if this string's length is 62.5 centimeters and its note is properly tuned to 261.6 hertz? So a piano string is going to rest over two bridges where the string is going to be allowed to vibrate up and down in the middle, but it's not allowed to vibrate at the position of the bridges. So we can have our string go up and down like this in the middle, and that's called an antinode. But these points where it's fixed to the bridge are called nodes. It's not free to vibrate there. So the problem is saying the length of the string from one node to the other is going to be 62.5 centimeters. But that is not the wavelength of this string. In order to show the complete wavelength, we have to show that this is only 1/2 of the wavelength. We have to imagine that there could also be a trough, and this trough will complete the rest of the wave. So our actual wavelength becomes 2 times the length of the string. That's 135 centimeters. I'm going to convert the wavelength to meters though, and the way we do that is with a conversion factor. I'm going to put centimeters on bottom so that we cancel the centimeters. Put meters on top because that's the units that I want. The metric prefix centi stands for 0.01 of a thing, which is 1/100th of a thing. So we could say that 1 centimeter is defined as 0.01 meters. This has the effect of moving the decimal back 2 places, so our wavelength in meters becomes 1.35. I would now want to use the wave formula, V equals lambda F, in order to determine the speed of the wave. V stands for the wave speed. Lambda is the Greek letter standard for wavelength, and F stands for frequency. We now know the wavelength and the frequency, so we can solve for the wave speed on the string. It's 353 meters per second.